This is video number 40 in the playlist for 3D Experience CATIA, the generative shape design application. It's also applicable to the part design because the access system that I'm going to be talking about appears both in the generative shape design and the part design. But the environment that I'm going to show you is going to be generative shape design. So when you are in the generative shape design, GSD, if you select the wireframe, there is a pull-up, there is a menu ribbon here, and the access system is right there. Okay, and when you click on it, this dialog box opens up, and there's a few things that you have to do, and we look at it in the context of an example. But there's also under this tab, there's a pull-down menu. So I'm going to look at the three cases and go through it with you one by one. Now, the access system standard is right there. Then when you look at the axis of rotation with that option, the menu is a little bit different. And finally, when you look at the Euler angle, you have to input Euler angles, and the convention that's used, although not explicitly mentioned, is the 313 Euler angle or ZXZ. Also known as ZXZ. Okay. Here is some information about the limited number of pages for the online documentation. Yeah. Okay, so let's go ahead. And what I'm going to do is, I am in generative shape design. I'm going to make a box here. You'll see why I want to do that. I'll draw a rectangle. Exit. Now, since I want to make a box, here I have to do it as a volume, which is fine. So let me pull this thing up. There we go. Okay. And I'm going to hide this sketch. All right. So there's my box. Now, select the wireframe, and here is the access system. You click on it. First, we're going to look at the standard. Now, this creates a local code. If you don't do anything, it's going to create a local coordinate system, access system with its origin at the global origin as shown here. Remember, the global origin is an intersection of these reference planes, without doing anything else, the origin of that coordinate system that it creates is going to be at the global origin. Now, if I want to choose a different one, I'm going to go and select, for example, this point. Okay, so it puts it there. Aligned with the global coordinate system, but the origin is selected to be that location. Now, here you have the opportunity of reorienting this by selecting what you want. For example, suppose I want X. Suppose I want X to be on this axis. So I put the cursor in the X-axis box and go and select this edge. Notice what happens is that it put the X-axis along that edge. And in fact, if I wanted to, I can flip the arrows like that so we can see what happened here. So X is along that line, origin is there, and of course, because it's a right-handed coordinate system, this is going to be Z and Y. Okay, good. Say okay. Now, suppose you decided for some reason to rotate this thing about the x-axis by some angle. For example, let me select this, right click down here. Now, rotation is not there, so what you do is you select double click on the axis, the one, and you want to rotate it about the x-axis by 45 degrees. So put the cursor on the x-axis right here, right click, rotation. Positive rotation about the x-axis by 45 degrees. So you click on it, and there is a number and you put down 45, and you say okay, and close it. So notice what happened is that it was rotated about this x-axis by 45 degrees, and because it's positive, it follows the right-hand rule, the thumb up in the direction of x, and this is what you get. Good. Now, let me do another one. Axis system, but this time I'm going to use axis and rotation. Instead of standard, axis and rotation. The default, the default is the default is at the at the default origin right now, which is this location. No, I don't want it to be there. I want that location. Okay, that location. And the x-axis, I want it to be on this line. See that? On this line. X-axis on this line. Good. And the angle that I measure from a plate, reference plate, so I'm going to use this reference plate. So angles are measured with reference to this plane. So I select it. Look at what happened. Look at what happened. X this way, Y down. Now, if I want to flip Y, goes up so that it becomes kind of similar to this when I had it. So let me flip Y. Okay. And now I want to rotate this thing by 45 degrees. 45. And then you say, okay. Notice that these become identical. So although I created this thing a different way, namely by using the axis rotation, but it gives you the same thing because that's exactly what it does. Let's do another one. Axis system. This time I'm going to use Euler angle. And let me select a different origin, for example, right there. By the way, these dashed means that these are not current. They are with respect to the global origin. Okay? What I mean is that they're not current. And as soon as you click on the axis system, it's going to put it right there. This is your global origin. Okay? So I'm going to select origin to be right there. Okay? And Euler angle is basically a method for rotating this thing. First rotating about the z-axis because it says zxz. Rotating, I think it was, what is that, 313? Let me just check. Yeah. First rotating about the z-axis. Let me show you by some angle. Look, I'm going to angle 1. Look what happens to, let me move this thing out of the way so you can see it. I'm going to change the first angle. It's going to be rotation about the positive z-axis. Look. It is going the positive z-axis. The second one is positive new x-axis. The new x-axis is right here. The new x-axis is right there. See that? Right there. So, see, it's rotating about that new x-axis positive. And then the last one is the new z-axis, whatever it is, right here, in the positive sense. There we go. So this is how you get to create a coordinate system and orient it based on the Euler angle configuration. Yeah, that's all. Because this is solid, means that this is my active system. So when I click on this axis system for another axis system number 4, it's going to put it at the origin of the active coordinate system. The coordinate system that's active is this. So if I click on that, it's going to put another one right there. Cancel that. I want to show what happens. If you make this thing not as current, you put the cursor on it, and you say not set as not current, it becomes dash. And when you click on this, it's going to put it at the active coordinate system, which is the global coordinate system, which means right there. So if I click on this, look at where it put it, right there. Okay, good. That's pretty much it. It's a very important thing that you need in CAD and in CATIA if you want to do modeling. All right, folks, good luck.